All right, folks, let's go ahead and talk about the domain for this one. So from left to right, what is the first x value that we get for this graph? Roughly -4. So that point looks like it's about at -4, -1. So -4, using interval notation, would be the first value that we get. Bracket, because that point exists and it is a closed dot on our graph. Then, as we go to the right, where does this interval end? What x values get covered? The rest of them, because we keep getting covered all the way to infinity. That is what your domain would look like using interval notation. Using inequality notation, we would say that they're covered for x values, what than -4? Greater than or equal to. We start at -4 and are covered going to the right. Raise your hand high if you got that one right. Raise your hand if you used interval notation. Raise your hand if you used inequality notation. Okay, good to know. Let's go ahead and look at our range values. Now, range is a little bit, I just drew all over my hand. Range is a little bit tricky for this one because this arrow just keeps going down, 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 down. So from the bottom up, what y value does this graph start with? -infinity. Where do my y values end? We're covered, we're covered, we're covered, we're covered, we're covered, and this one just keeps going up. Where do my y values end? Infinity. It just keeps going all the way down and all the way up. So -infinity to +infinity using interval notation. For inequality notation, we would just say all real numbers or aren't. Is this a function?
Yes.
If we put a vertical line here, it's only hitting in one spot, but anywhere else, it's hitting in two spots. And going back to our blender example that we did yesterday, we could look at these 2 points and say that's 0, 3, and this is 0, -5. If we think of our blender, if I put in 0 and I get 3, and then an hour later I plug in 0 and I get -5, does that appear to be a working machine or a working blender? No, we shouldn't be getting different outputs. So your vertical line test is essentially finding if there are any domain doubles. So, nope. Fails VLT. You can also write because there are domain doubles. And for the final part of this, is it a one-to-one function? If something is not a dog, do we want to ask if it's a corgi? No, if it's not a function, it can't be a one-to-one function. So if it's not the large group category, it can't be the more specific category. So if it's not a word blender, it can't be one of those unique blenders where we have the same input and output. So we don't put anything. You can put NA for not applicable, but it wouldn't even be appropriate to say, no, it's not a one-to-one function. We just don't write anything. Turn the page. Hey, what type of graph are we looking at here? It's a cubic. Woohoo! So is a cubic function a function? Yep, it sure is. So yes, because we know the cubic function is one of our 5 basic functions. But you can also say it passes the VLT. Now, what about being a one-to-one function? Sometimes students get kind of sketched out by this stuff in here. It's like, ooh, are there multiple points occurring there? If we think of our parent table, -1, -1, 0, 0, 1, 1, somewhere in there-ish, my graph is curving up through those points, just like a parabola curves up through those points. There's no y value match on the other side, so this would be 1 to 1. There are no range repeats for cubics. In fact, for cubic functions, it's one of those special ones that it is 1 to 1, and it is also a function. And you can say it passes the HLT. Okay, so domain and range for this one. Remember that when you have an equation that defines the function, which we have here since this is a cubic, you can also think about the domain being the x values that you are allowed to plug in. Is there anything we can't plug in for x? Nope, I can plug in negatives, I can plug in positives. We can plug in anything. So what do you think our domain is? All the x values, it's all real numbers. You can also see it visually from left to right. This line is going to keep going outward. This one is going to keep going out and to the right. So all the way left and all the way right. Domain, all real numbers. In interval notation, negative infinity to positive infinity. Parentheses because we don't actually reach those values. So take a guess at the range. Write down what you think the range is. Your range is all real numbers as well. Negative infinity to positive infinity. Alrighty. Moving on to the next one. Hey, go Warriors. It looks like a W. Love it. So this one's a little bit interesting because we've got kind of this up and down movement with our graph. So let's see if we can figure out what the domain is going to be as we look at our x values from left to right. So what's the first x value that we get on our graph? Well, this line is going to keep going outward. So what's the first x value we get as we keep going this way? Negative infinity. And this side is just going to keep going outward as well. So infinity. And all of those x values in between get covered by our graph. So negative infinity to positive infinity or all real numbers. Now, this is where students sometimes get confused. With range and with all domain and range values, when we talk about what's being covered, it's all the y values as a whole, not the ups and downs. So the y values as a whole, not the ups and downs. So folks, let's go ahead and find these bottom coordinates. It looks like this is at -2, -4, and that this one is at 2, -4. So from the bottom up, what does it look like the first y value we get on our graph is? -4 over here and -4 over there. So we're starting at -4, bracket or parenthesis if we're using interval notation. Bracket, because we're getting those values. They're solid points. Now, can we get a y value of -3? Yep, over here and over here. Over here and over here. Over here and over here. And then, sometimes students think that we stop at 0. But take a look at the left side of my graph and the right side of my graph. Those sides of the graph get 0, and then they just keep covering those values going upward. We get 1, 2, 3, 4, 5, all the way up to infinity. So this interval goes from -4 to infinity. So it's not like, well, it stops at 0, and then we jump over to this side, and it keeps going. We are just looking at what y values are covered by the whole graph, not concerned with the ups and downs. So then if we wanted to use inequality notation, what would we say? Y is what then? -4. Greater than or equal to. Is this a function? Yep, passes the vertical line test. I'm always only hitting it in one spot. Is it 1 to 1? Nope. And ooh, if I draw a horizontal line here, it's failing the test in 4 spots. So that's a big no-no. So nope, it fails the vertical line test. Or horizontal line test, sorry. All right, folks. So what I would like you to do is in your homework packet, you should be able to do #all on page 4. Remember, you can state the domain and range either using an equality notation or interval notation. I do not care which one. Just make sure you're checking those answers carefully to make sure whichever method you're using, you're doing it right. So it's just those 4 problems with multiple parts. This page will be due tomorrow night. Capiche? Okay. So that is what you can be working on once you are done with the homework quiz, which is what we're going to do next.